All right, well, good morning, good afternoon, good evening, whatever time you're watching the videos. Again, this is Math 41, beginning algebra, section 5.6a. We're going to talk about polynomials and multiplying them together. And the whole idea behind multiplying them together is so that we can kind of describe the world. Let's say if we've got, I'm going to kind of go over here and see if I can write something real quick. Let's say if I've got we just installed a pool over the summer. My wife wanted a pool, so we got a pool. So let's say, just for fun, I've got a 50 foot by 40 foot pool, and you know what, that's not really the dimensions, but let's just say for the purposes. So I can figure out how much square feet that I've missed in my yard because of that. But now let's say I wanted to add something like a deck around it, and I want to say I want it to be X feet out. How much more square footage would I lose? Well, I could say that if this were now 50 plus x and 40 plus x, now I could say that, well, the total square footage would be 50 plus x times 40 plus x, and that would be the polynomials. That would be 50 plus x. My total square footage would be 50 plus x times 40 plus x, 40 plus x. And there would be a polynomial times a polynomial. That would give me my total square footage, and that would give me a better estimate of the square footage right there in general, instead of having to go back and say, well, if I added 2 feet, if I added 3 feet, if I added 4 feet, I'd have to calculate that all the time. I could describe the entire square footage of my pool plus the deck, giving that new polynomial, and that would be multiplying these two polynomials together. So that's what we're going to do today. 5.6 section A is going to talk about multiplication of polynomials. And by the way, just a reminder, take notes. It's going to be a good idea to take notes so you can refer back to those notes often. Make sure you take a picture of that, put it in the Dropbox, and make sure that in this video especially, we're going to have a couple of times where at least once we'll pause the video, and I'll say pause the video, do some of the work, and that'll be the time for you to kind of do some work yourself. So make sure you pause the video, and then at the very end we'll have a problem to do, and you can hand that in as well with your notes to the Dropbox to make sure that you can get into class. Alright, so that said, we're going to talk about multiplication of polynomials. Really, multiplication of polynomials is really just paying attention to what's being multiplied together, including signs and including bases, and we'll take a look at a lot more specific information later, but really just pay attention to what you've got, including the signs and the bases, and you'll be okay. We're going to talk about the rules of exponents. A lot of times math, just like life, is kind of best understood backwards. So we're kind of looking backwards now, what we've done in section 5.1 through 5.3. And oh, by the way, I've taken the liberty of copying from the book, table 5.1. These are kind of all the rules that we've got from exponents, or I guess for exponents, about exponents, and exponential properties that we can use now in our in multiplication. So all the rules are kind of written down here, summarized from the book. It's also in the book. I forget what page it's on. It's somewhere in section 5.3, page 357, I think. Page 357. So take a look at that if you need. All the rules are right here, though. So let's go back and kind of see how we can apply some of those rules. What we're doing right now is talking about the multiplication. So we're talking about multiplying polynomials, and really we're talking about a couple different ways that we're going to multiply polynomials. We can multiply a monomial. Remember, a monomial is a polynomial with just one term. We can multiply a monomial by a monomial. That would be one way we could do it. Multiply polynomials. We can, for all of our intents and purposes right now, we're going to talk about the second option would be multiplying a monomial times a polynomial that's not a monomial. That would be a binomial, a trinomial, or anything bigger. And then, so that'd be one type of multiplication would be monomial times monomial, then monomial times a polynomial, and polynomial then is the final one, polynomial times a polynomial. And that would be anything bigger than a binomial or larger, multiplied by a binomial or larger. And then we can also get more and more terms. And really, from here on, we just got to pay attention to multiplying every term in the first times every term in the second. So how do we do that? Well, here are the rules again. We can take a look at them as you need. I'll pause right here, I guess, if you need. But we're going to try and apply some of these rules. So again, the first one we're going to talk about, first type of multiplication we're going to talk about is a monomial times a monomial. So we got monomial times a monomial. We have to pay attention to the signs. We have to pay attention to the numbers. We have to pay attention to the variables and the exponents together. So what do I need? What do I mean by that? I guess. Well, I've got 3 x to the 4th. That's my first polynomial, which is a monomial. I'll underline that in green. I've got my second monomial, or second polynomial. I guess it's a monomial. There's my blue one. And what I can do is I can say, well, let's take a look at, first of all, multiplying signs together. Well, this right here, for this polynomial, this monomial, this is a positive sign here. It's not written, so we have to assume there's a positive there. There's a positive here. It's not written, so we assume it's a positive. So our sign for the multiplication is a positive times a positive is a positive. We don't have to write it down, but just for our intensive purposes right now, we'll write down the positive. We have to take a look at the numbers. What are the numbers? We have to, well, let's see. In order to talk about that, we can talk about multiplying these together and saying, let's take an aside over here. And I'm going to say it's 3x to the 4th times 4x squared. And I'm going to say, you know what, I'm going to multiply those together. How do I do that? Well, we talk about a couple different rules in multiplication. If we're multiplying things together, we can choose to move things around if we're multiplying all these together. This is a 3 times x to the 4th times 4 times x to the x squared. And we can choose to say, you know what, I'm going to rewrite this in terms of, well, let's see, this would be the commutative property of math, or multiplication, I guess. And I'm going to say that's 3 times 4 times x to the 4th times x squared. And all I've done really is move the 4 over here to be kind of commuting over here. The word commutative property, not such a need to know. It's kind of a nice to know. The important thing, the need to know, is that you can move that 4 over here and multiply it by the 3 first. And then we can associate these together, and that's the associative property. The 3 times the 4 gives us 12. We can associate those together. We can associate these together and say that's x to the 4th times x squared. And if we apply those rules that we have in the previous page, that would be x to the 6th power. So there's really our answer. We've kind of taken an aside over here and kind of answered it here. But here's our answer. 12 times x to the 6th power. And there's our answer. Applying the commutative property, meaning we can move that 4 over here and kind of then associate these two together, the 3 and the 4, and the x to the 4th times x squared together. That's the associative property. But basically, if you know that you can move these around together, move them around before multiplying, and then associate these together and associate these together, you're going to be okay. And that's the need to know. So if we multiply these two together, these polynomials, a monomial times a monomial, we will get this. 12 times x to the 6th power, or 12x to the 6th power. And that would be our answer. All right. So a couple of other possibilities here. I'm going to ask you, or maybe tell you, to stop the video here. Go through a monomial times a monomial, monomial times a monomial, 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 and multiply all these together. See what you get. Pause the video. Come back to it when you get an answer. Do it in your head, whatever you need to do, but make sure you do it. We'll come back. Okay, let's do this one together. We can take the long way around and kind of commute things around and say, well, this would be -4. I don't know. Oh my gosh, hang on a second. Let's see if I can do this again. There we go, that's better. And let me erase this. This is -4 times 2 times all the c's together, c to the 5th times c squared times d cubed times e. So we've kind of done all the commutative and associative kind of together right now. These should be associated together, but we can do that right now. -4 times 2, -8, c to the 5th times c squared. You add the exponents, c to the 7th, d to the 1st. We have to remember that's an unwritten exponent, so we have to assume it's d to the 1st times d cubed is d to the 4th power. E is just by itself, and that's e to the 1st power, unwritten, but we'll just leave it as that. So there is the answer for that one. For this one, we have to we can take the long way around and kind of rewrite things. If you need to, go ahead and do that. Rewrite things so that the c to the 5th and c squared is together. Over here it'd be a to the fourth would be alone, but b cubed times b seventh would be together, but we don't really have to do that. Well, it might be easier to write this 1/3 times 3/4 together, and then just write everything else. A to the fourth, b cubed, b to the seventh, multiply everything together because this is what's left. 1/3 times 3/4, we can cancel the 3's because 3 divided by 3 is 1, so we have 1/4 left over, and a to the fourth, b to the 3 plus 7 is b to the 10th power, and there's our answer. Again, I only put these together as fractions just because it might make it easier to look at as they're associated together over here, multiplying them together. What do we get down here? I'm going to fast forward with some of this stuff. Negative 30 y to the fourth power. Don't forget that's a y to the first. Y to the first times y to the third is y to the 1 plus 3 is 4. Over here, negative 14, 7 times a negative 2 is negative 14. X to the fifth power, x to the second times x to the third power is x to the 2 plus 3 is 5, y to the fourth power. And then we get over here, I'm going to again associate these again, 2/5 times 15 fourths multiplied by everything else, w to the, well, we can even take the shortcut here, w to the ninth power, z cubed. And then to simplify it, we'll just kind of simplify the fraction and say 5 and 15 cancel because to get to 3, how many 5's going to 5? 1. How many 5's going to 3? Sorry, 15, 3. 2 and 4 cancel with a 2 down here and a 1 up here. So this would be 3 halves w to the ninth power z cubed. And that should be our answer right there. Alright, how did we do? Any questions? Bring them to class. Let's go on to the next stuff. Alright, so right now we've got, so that was monomial times a monomial. Remember, we've got a monomial times a polynomial now. So the next step would be monomial times a polynomial. And the polynomial I'm stating here would be anything greater than a monomial. So a monomial times a polynomial greater than a monomial. Again, we've got to take a look at the signs. Take a look at the numbers, kind of associate those together. Take a look at the variables that are similar, like the x's, group all those together, and the exponents on those variables. And then we have to use the distributive property for this one because we've got to really essentially multiply what's outside here times everything that's inside. So we use the distributive property here to multiply everything over here. Just like over here, we've got a times b plus c is a times b plus a times c. So we're going to do the same thing over here. We've got 2t times 4t, and we're going to write the long way here. 2t times 4t plus 2t times negative 3. Now here's the long way around. We're going to do this again. 2t times 4t, we could dissociate the 2 and the 4 together first, but we don't really need to. We can just say that's going to be 8 times t, or t to the first power, times t to the first power is t to the second power, or t squared, plus negative 6 times t. And then we can simplify things as well. Here's 8t squared minus 6t. And there's our answer. So now I'm going to invite you to stop the video, work on these on your own, or at least stop the video, do them in your head, and say, all right, well, you know what, this should be that should be this, and there's my first, second, third, four terms. Either way you do it, make sure you stop the video now, take a look at it, and go from there. Alright, here we've got a monomial. Again, this is the next step, monomials times polynomials that are bigger than monomials. So here's my monomial times a polynomial that's bigger than a monomial. So what we have to do is, again, use the distributive property to distribute this outside term to everything that's in here. And we can take a look again. When we're multiplying a term times a term, we have to look at the signs, we have to look at the numbers, because we're going to associate the numbers together, and we're going to look at the variables, because we're going to associate those variables that are similar together. So let's take a look at this. What is a sign? Negative times a negative is the first one. We can take a shortcut and say negative times a negative should give me a positive. 3 times 4 gives me 12. A squared times a squared should give me a to the 2 plus 2 is 4. The next term is a negative times a positive should should give me a negative. 3 times 2 should give me a 6. A squared times a to the first power should give me an a cubed. The third term is this outside term multiplied by this last term. Again, we take a look at signs, numbers, and variables. What are the signs? Negative times a negative gives me a positive. 3 times 1/3, if we need to take that out as an aside, let's say, it would be 3 times 1/3. And if you need to, you can say that's 3 over 1 times 1/3. 3 over 3 cancels out, and we get just 1. So our number should be 1. We can write it or not. Let's choose to write it just so that we know that the 3 times 1/3 is 1. A squared times no a, or a to the 0th power, is just a squared. And that's our answer. All right, for this one, this should be pretty straightforward as well, because now it's going to be an outside term, a monomial. Again, we're talking about monomials times the polynomial that's greater than a monomial. We have to do the distribution, use a distributive factor, or distributive power, distributive rule, and talk again about signs, numbers, and then variables. What's the signs? A negative times a positive. There's an unwritten rule there that there's no sign there, so it has to be positive. Negative times a positive is a negative. 4 times 5 is 20. A times a, or a to the first power times a to the first power, gives me an a to the 1 plus 1 is 2. And now the second multiplication would be the outside monomial times the second term in the inside polynomial. Negative times a negative is a positive. 4 times 3 is 12. A times 1, or a to the 0th power, is a to the first power, or just a, and there's our answer. All right, last one. We'll go with green over here again. All right, maybe again, outside term, the monomial times everything inside. You just got to pay attention to distributing this term, multiplying by every term that's inside that second inside polynomial, or that second monomial, or second polynomial that's greater than a monomial. So again, we take a look at signs and numbers and variables. What are the signs? Negative times a positive is negative. 4 times 2, 8. P to the first power times p squared is p to the 1 plus 2 is p cubed. Second term is negative 4p times negative 6p. Again, the entire term is negative 6p, so negative times a negative, positive. 4 times 6, 24. P to the first times p to the first is p squared. Add the polynomials add the exponents when we multiply those variables. Third one, negative times a positive, negative. 4 times 1/4, real similar to this one here. If we need to take an aside, we can say that, well, this is 4 times 1/4. As numbers, well, it's 4 over 1. The 4's canceled out because 4 divided by 4 is 1. Now we have 1 times 1. 1 times 1 gives us a minus 1. We don't have to necessarily write that, but we can for this exercise. P to the first times p to the 0, or 1, is p to the first power. And we can write it as p to the first power, or just p. And there's our answer. How did you do? Okay, that's the kind of idea behind multiplication of monomials times something that's a polynomial that's bigger than a monomial. So the next step is really just making things just a little bit more difficult. So we're going to now take a polynomial, multiply it by a polynomial, and that polynomial is, again, something that's, in this case, a polynomial that's bigger than a monomial, binomial, trinomial, etc. Same thing by multiplying by a binomial, trinomial, etc. And now we'll have to use the F word. And I say that with a little bit of a grin on my face, and I say this is the only time that you can use the F word in math, and we're going to use the FOIL method, especially for a binomial times a binomial. In fact, that's probably the only time, that is the only time we can use that FOIL method, because the FOIL method means you multiply the first terms, multiply the outside terms, multiply the inside terms, and multiply the last terms. So what we have to do, again, is just pay attention to what we're doing. We're multiplying every single term. If we're multiplying a polynomial times a polynomial, multiply every single term in the first polynomial times every single term in the second polynomial. So if we follow the FOIL method to be the first, the outside, the inside, and the last. Oops, sorry, the last. Kind of making a smiley face there. So let's do the first term. First term would be c times c, or c to the first power times c to the first power would give us a c squared. Outside terms are, let's see, hang on a second. Outside terms would be c times 2, and that would be, again, we have to take a look, I guess, at signs, numbers, variables. Sign is positive times a positive gives us a positive. Numbers is 1 times 2 gives us 2. Variables is c times nothing is just c. Alright, same idea here for the inside terms. First outside, inside last. Inside is 7 times c, but we have to take a look at negative 7, because that's the term, times a positive c, and that should give us just a negative c. We can go through the, or sorry, negative 7c. We can go through the whole process of negative times a positive gives us a negative, 7 times 1 is 7, nothing, or c to the 0th power times c is c. Alright, and then the last terms is going to be 7 times 2, or sorry, negative 7 times 2, because the term is negative 7. Second term, or the last term in this one is positive 2, and that would just give you negative 14. And now we're almost done, but what we have to do is now make sure that we combine like terms and get an answer of c squared plus 2c minus 7c is minus 5c, because those we can, again, those are like terms because they have exactly the same variable to exactly the same power, and then minus 14. And that is our answer right there. Alright, pause the video. Look at this one. This again is a FOIL question. This is a FOIL question. Here's a FOIL question. If you want to do one or two of them, go ahead and do it and just get the idea of it. I'll ask you to pause the video and we'll come back. Alright, first terms, outside, inside, last. First, outside, inside, last. First, outside, inside, last. Alright, let's see what we can do. First, x times x, x squared. Outside, 8x times 8. Again, positive times a positive, positive, 8x. Inside, positive 2 times positive x plus 2x. Last, 2 times 8. Again, positive 2 times positive 8 gives us a positive 16. Now, last step is just combine like terms. Now, hang on a second. We're going to combine like terms, and then we get x squared plus 8x plus 2x is plus 10x. We can do that because x and x are the same. Same variable, same power. Plus 16, and there's our answer. Alright, we're going to fast forward through some of these. 10x times 2x. First, outside, inside, last. You can use that darn F word. FOIL method. 20x squared. Outside, minus 40xy. Inside, plus 6xy. Last, minus 12y squared. I didn't highlight these just because it takes a little bit more time and it's also a little bit more confusing. But again, we went first, outside, inside, last. Now we got to take a look at any like terms. We got the x squared doesn't have any like terms because it's an x squared. This is a y squared that doesn't have any like terms because it's a y squared. Here's an x and a y, xy. Same exponents, or sorry, same variables, same exponents. Now we just combine them. 20x squared minus 40xy plus 6xy is minus 34xy minus 12y squared, and there's our answer. Alright, last one. Again, we're going to use the FOIL method here. First, outside, inside, last. Let's do first. 4a times 5a, 20a squared. Outside terms, minus 8ac. Inside terms, minus 15ac. Last terms, plus 6c squared. Again, we're multiplying the first terms. Outside, inside, last. Pay attention to what you got for signs, numbers, and variables. Then combine the like terms here. And what do we got? We've got, again, combine the like terms. 20a squared doesn't have any like terms. minus AC minus 15AC, those are like terms because they have exactly the same variables, exactly the same powers. Minus 8 minus 15 minus 23AC, and then plus 6C squared. And there's our answer. All right, let's see what we can do here. You know what? We're going to call this a day with this one and say enough. Any questions, bring it to class. Make sure you take the notes, put the pictures on the Dropbox, and show that you did the problem. Let's see. Hang on 1 second. Let me go here and say, all right, for this one here, question to bring to class. Let's go here. Here's the question to bring to class. 2x plus 3 times 5x plus 2. Bring that to class. Solve it, or at least, show it that you can do that. Again, use the FOIL method. First outside, inside, last, and show me what you get for the answer. All right, bring it to class. Put it in the Dropbox, and we'll see you soon.